Hello guys, in this video we are going to solve for wedge acceleration in seconds. This is the part 1 of the series of videos for NEET and JEE. By watching this particular video, you can solve for any wedge system. So again, welcome to IB360. So over here we have a block of mass m1 and a block of mass m2. The block of mass m1 is actually going downward with an acceleration of a1 and the block of mass m2 is going towards the left with an acceleration a2. So in this video we are going to discuss how to find the relationship between the acceleration a1 and a2 with the help of a short trick. So over here, if we analyze the motion of the block of mass m2, the block of mass m2 will actually move in the leftward direction. So that means if the block of mass m2 was initially over here, after some time it will move in this direction, that is towards the left, and finally it will be towards here. Okay. So over here, see that I have drawn the block of mass m2 for two consecutive times, 1 and 2. So over here what you need to do is that, see, the point of intersection between the two triangles is this. Okay, and the point of intersection between the two triangles is also this. Okay, so now draw a line parallel to the base. Okay, so this is the line parallel to the base, and draw a line parallel to the height. So this is the line that is parallel to the height. So over here, see that this is the triangle that is being forming. Okay, so let us name this triangle as A, B, C. So this triangle is of utmost importance. So over here, as the block of mass m1 is actually moving downward, okay, so in the triangle ACB, this part is actually downward, right? So that means over here we'll plot A1. So over here along the side AB will be our A1. Okay, so again see that as the block of mass m2 is moving towards the left with the acceleration a2, in the triangle ACB, which is towards the left, this side AC is towards the left, right? So that means over here we'll plot A2. In this manner we'll be plotting A2 in this direction. Okay, and see that over here this angle, the base angle is theta. So over here write the base angle to be theta. So if this angle is theta, this angle will be also theta, right? So that means we have successfully found a triangle and we have plotted along the sides of the triangle the acceleration. Along the side AB is our A1 acceleration, which is pointing downward. Along the side AC we have our A2 acceleration, which is pointing towards the left, and we have an angle theta. Okay, so over here from this triangle, can I write that tan theta? So what will be tan theta? Tan theta will be AB upon AC, the side AB upon AC, right? So that means along the side AB, we have plotted A1, right? So that means for the side AB we'll be writing A1. Okay, and for the side AC we have plotted A2, right? So that means for the side AC we'll be writing A2. Okay, for AB we have plotted A1 and for AC we have plotted A2. So we are substituting that. Okay, so that means from here we get that the relationship between the accelerations will be A1, this should be equal to your A2 tan theta. Okay, so using this trick and using a little geometry, we can easily find the relationship between the various accelerations. So proceeding on to the second question, over here again there are two blocks m1 and m2. M2 is sliding down the block of mass m1 with an acceleration of a1 down the incline, and m1 is moving towards the left with an acceleration of a2. So we need to find the relationship between the accelerations a1 and a2. So again what will we do? So we will again observe the motion of m1. So over here see that as the block of mass m2 is sliding down the incline with an acceleration of a1, the block of mass m1 is actually moving towards the left, right? So if we observe the block of mass m1, it is actually moving towards the left. Okay, so that means if at one instant the block of mass m1 was over here, after some time what will have? It will travel towards the left and it will reach this point. Okay, so that means we are drawing the block of mass m1 for two consecutive units of time. One is time 1 and one is your time 2. Okay, again the two triangles, they intersect each other at this point and this point. Okay, so again what we need to do is that we have to extend this line parallel to the base, and we have to extend this line the parallel to the height. Okay, so by doing so what we'll get is that we'll get a triangle. This point and this point will constitute a triangle. Name this triangle as ABC. Okay, so we have a triangle ABC. Now we need to plot the acceleration along the triangle ABC. Okay, so see that over here M2 is actually sliding down the incline, right, in this manner. So the acceleration of M2 is actually in this manner, it is tilted by an angle of theta. So that means in the triangle ABC, which side will represent the acceleration A1? Yeah, this side. The BC side will give us the acceleration of A1, because see, the acceleration of A1 is at an angle theta, right? So that means over here, and the BC side is also at an angle theta with the base. So that means over here the acceleration A1 will be along the side of BC. So this will be our acceleration A1. Okay, and see that the acceleration of A2 is actually towards the left, right? The acceleration of A2 is actually towards the left. So that means which side will accurately plot the acceleration of A2? The acceleration of A2 would be accurately plotted by AB side, right? So that means it is moving in this manner towards the left. So that means the acceleration A2 will be towards the left. Okay, so this will be acceleration of A2. Okay, and see that again this angle is theta. The angle of the wedge is theta. So that means if this angle is theta, this angle will be also theta. So in the triangle ABC, I can write that, see over here what can I write? I can write that cos theta will be equal to your AB upon BC. Okay, now see over here what will AB correspond to? AB will correspond to the acceleration of A2, whereas the side BC will correspond to the acceleration A1, right? Because on the side AB we have plotted the acceleration of A2, and on the side BC we have plotted the acceleration A1. On simplifying, we can write that A2 will be equal to your A1 cos theta. Okay, so proceeding on to the next question. Over here we have a rod of mass m1 which is moving downward with an acceleration of a1, and we have a block of mass m2 which is moving towards the left with an acceleration of a2. So again we need to find out the relationship between the acceleration a1 and a2 with the help of the same method. Okay, so that means over here we have to analyze the motion of your m2. So suppose the block of mass m2 was at this point at time t1. So after some time what will happen? It will shift towards the left. Okay, so and it will shift towards the left and reach this point too. Okay, triangles are cutting each other at this point and this point. Okay, again the same method, you have to extend this line parallel to the base, and you have to extend the line parallel to the height. So by extending the line parallel to the base and parallel to the height, we will get a triangle. Okay, so name the triangle as your ABC. Okay, so in the triangle ABC, so you need to plot the accelerations. Okay, so see, the block of mass m1 is actually going downward with an acceleration of a1. Okay, so that means which side of the triangle ABC will be plotted for mass m1? This side. Okay, as the block of mass m1 is going downward with an acceleration of a1, so this will be plotted in the side AC, and the acceleration will be a1. Okay, so that means along the side AC we'll be plotting our acceleration a1. Okay, over here see that the block of mass m2 is moving towards the left with an acceleration of your a2. So that means which side of the triangle ABC will plot a2? Along the side AB or along the side BC? See, along the side BC, if we place acceleration, it will be at an angle downward, right? So that means the BC side is not correct, but along the AB side we can always place the acceleration towards the left. So that means we will plot the acceleration a2 along the AB side. Okay, so that means this will be our acceleration a2, which is the acceleration of the block of mass m2. Okay, see, again this angle is given to be theta. Okay, so that means if this angle is theta, this angle will be always theta. So again what we can apply from the triangle? So from the triangle ABC, tan theta will come out to be, tan theta will be what? AC upon AB. Okay, so along the side AC we have plotted a1, right? So that means for AC we will have a1, and for AB we will have a2. Okay, so why a1 and a2? Because for this side AC we have plotted a1, and for this side AB we have plotted a2. So that means by simple calculation we get that a1 would be equal to your a2 tan theta. Okay, so that means by the simple geometry we can get the relationship between the accelerations a1 and a2. So over here let us now take a question. So over here there is a sphere of radius r. So this is the sphere of radius r. the wedge is moving with a velocity of 20 meter per second towards the left. Okay, so that means the wedge is moving towards in this direction with a speed of 20 meter per second. So that means if the wedge is moving towards the left with a speed of 20 meter per second, the sphere has to move upwards, right, in order to accommodate the space. So that means we need to find the speed of the sphere that is moving upward. Okay, so that means we will apply the same method as we have applied in the previous 3 questions. Okay, so over here first we have to analyze the motion of the wedge. Okay, see over here the wedge is actually moving towards the left. Okay, and suppose this is the wedge at the time t1. Okay, so that means after some time the wedge will travel towards the left and it will reach the point 2. Okay, so that means again see in between these two triangles this point and this point are in common. Okay, so that means we have to extend this side parallel to the base and we have to extend this side parallel to the height. So that means on extending the points parallel to the base and parallel to the height, we will get a triangle ABC. Okay, now we have to plot the acceleration or the velocities along the triangle ABC. Okay, see over here the wedge is actually moving towards the left. Okay, so that means in which side of the triangle we will plot the velocity of the wedge? We will plot the velocity of the wedge in the side AB. So that means the velocity of the wedge will be plotted along the side AB and it will be 20 meter per second. Okay, and over here see that the sphere is actually moving upward. Okay, so that means over here on which side of the triangle ABC we will plot the velocity of the sphere? So we will plot the velocity of the sphere on the side AC. Okay, on the side AC. So that means on plotting the velocity of the sphere on the side AC, we will get a velocity. Suppose the velocity of the sphere be V. So okay, so that means over here we will get V. Okay, now see that suppose this wedge has an angle theta. Okay, so that means this angle will be theta. Okay, so from trigonometry I can write that tan theta, so this will be equal to your AC over AB. Okay, and along the side AC we have plotted V, and along the side AB we have plotted 20 meter per second. Okay, so along the side AC we have plotted V, we are substituting V instead of AC, and along the side AB we have plotted 20. Okay, so that means over here we can write that, so V, so that means the upward velocity of the sphere will be nothing but 20 times of tan theta. Okay, so now we have to calculate this theta. Okay, so over here we have drawn the sphere and the wedge. So over here see that this is the radius of the sphere and this is the distance r/5 from the ground where the contact of the sphere and the wedge is located. Okay, so over here we have also drawn the radius from the origin to the point at which the sphere and the wedge are at contact. Okay, and by simple geometry we can show that if the angle of the wedge is theta, this angle will be also theta, right? So that means over here let us name this point as X, this point as Y, this point as Z, and this point as M. Okay, so what is the distance XY? So XY is nothing but the component of R along XZ, right? So that means XY will be equal to your R cos theta. Okay, so that means this distance will be equal to your R cos theta. Okay, and the total distance from the point X to the point Z is R. So this total distance is R. So over here YZ can be written as XZ minus of XY, right? So now over here what is XZ? XZ is the radius, right? R. What is XZ? This distance from here to here. So this is R. Okay, minus. So what is XY? XY we have found out this distance, right? XY to be R cos theta. So that means over here this will be R minus of R cos theta. So that means the distance YZ will be equal to your R times of 1 minus of cos theta. Okay, and this distance yz is actually r by 5 from the ground, so that means r minus of r cos theta, so this will be equal to your r by 5. So that means over here 1 minus of cos theta, so this will come out to be 1 by 5. So from here we get that cos theta is nothing but your 4 by 5. So if cos theta turns out to be 4 by 5, from here we can get that tan theta will be equal to your 3 by 4. So over here if I just substitute tan theta to be 3 by 4, we will get that V will be equal to 20 into 3 by 4. So from here we will get that V will be nothing but equal to your 15. So that means the correct option to your question number 35 will be option number B, 15 meter per second.